All right, Ledger, here we go. So, today, oh man, it is 5:28. I love it. 5:28:19. So, navigation. Two ships leave port at the same time. Ship A travels at a bearing. A bearing, what the heck? Bearing. North 25 east. What does that mean? Well, we're gonna look north. Okay, watch my pencil. We're going to look north, and then we're going to turn 25 degrees towards the east. Does that make sense? I'll do it again. We're going to look north, then we're going to move 25 degrees towards the east. That's where my boat is heading. That's my bearing, okay? So then the next one is going to be on a bearing of south, 40 degrees east. So this boat's going to look south, and it's going to rotate 40 degrees towards the east. So what I'm going to do is I'm going to put port maybe right here. Call it P for port. And then my boats are going to look at their compasses, okay? So I'm going to put my compass here. The compass rose, or whatever you want to call it, but I like to put this in here. It's like my compass, north. And north is 0 degrees. East, which is 90 degrees. South, 180, and west is like 270, or negative 90, okay? So when you do a compass, whether you're navigating on an airplane or in the woods, right, or on a boat, the north is up at 0 degrees. So when I put my protractor on my compass, I do it like this. Do it like this, so that north is right here at 0, right? And then we're going to rotate clockwise instead of drawing angles, which rotate the other way. So on a boat, I look at my compass, I'm at north at 0 degrees, and now what I'm going to do is rotate 25 degrees toward the east. 10, 20, 25. So this is what direction my boat's heading, okay? Boat A is heading in that direction. 10, 25 degrees. So, all right, now boat A goes 12 knots. So I could draw this 12 centimeters, but it's going to go off my page, so why don't I draw it 6 and call it 12? You guys okay with that? So I draw it 6 and call it 12, okay? Here's boat A. We're going to call that, say that's 12. Even though I drew it 6, I'm scaling it down, and I've got 25 degrees there. How am I doing? Taking a boat trip. Boat A is going 12 knots per hour, so I drew its vector, or its journey, 12, because that's its speed. And that's 25. Now, ship B is going to point south. Okay, so let me go ahead and take my protractor, and I'm going to put my protractor on the compass, and I'm pointing south at 0. Okay? Oh, I might do it this way. 0 here. There we go. That looks better. So I zeroed it out, and I put it in such a way that I've got my 0, my 10, 20, 30. This is the lesson that tells you why I bought the circular one, okay? Because the circular protractors really make this problem easier, doesn't it? So I've got it zeroed out, and I can see my 10, my 20, my 30, my 40. So I'm going to go 40 degrees toward the east, so my boat's actually heading in that direction. Does that make sense? So I'm pointing south, and then rotate my boat 40 degrees towards the east. 10, 20, 30, 40, okay? And now I'm going to draw this one 8 knots. And 8 knots is way out there, but I remember I scaled it down, so I'll draw it 4 and call it 8, right? I'll draw it. So I'll call it 8, but I really drew it half that. So now this angle, okay, hold on.
Can you put the protractor down?
I would be happy to put the protractor back down, okay?
See how exactly how you.
So Gavin, I zeroed it out here.
Zeroed out.
And then I want these numbers, the inside numbers. The inside numbers would be 10, 20, 30, 40 degrees, okay?
Okay, so where did you start? Did you start on the bottom of the protractor?
Yes, because I'm heading south, right? So the bearing says south, so I'm heading south. So I'm looking south. See, I'm looking south, and then I rotate. So I'm boat south, and I rotate my boat 40 degrees towards the east. See how it works? I'm looking south, and I rotate my boat 40 degrees towards the east.
Okay, and is it also 12?
No, this one's 8 knots. So I drew it.
Okay.
I halved my scale, so I'm 4, yeah, but I call it 8, right? And there's boat B. Okay. This is 40 knots, or this is 40 degrees in here, okay? Now, how far apart are they? Well, we're going to draw that in. So what I'm looking for is this length right here. Good, good, good. We are going to add something, aren't we, Caleb? Go ahead. What are we going to do? Okay. Now, they're going to take a 3-hour journey on the same course, all right? So all we're going to do is make our triangle 3 times as big. Now, that'd be silly. I could draw it 3 times as big, right? But why don't I just leave the triangle the same size and just multiply these distances, or these speeds, times 3? Because go 12 miles an hour, so times 3. That means it's really going to go 36 miles or 36 knots. Same thing here. I'll take this 8 and multiply it by 3, and I'll make this 24. Because there's no reason to draw it 3 times as big. That means just more drawing, right? So let's just multiply the speed, because it goes 12 miles an hour, 12 knots an hour. So if multiplied by 3, it's gone 36 knots. Same thing here, it goes 8 knots per hour, but if multiplied by 3, it's got 24 knots. Okay, now the distance between them is here. Let's just call it C, okay? What I'd like to do first is find this angle. Because if I find this angle, I have my side angle. Side, yeah, it's super easy. So that angle, we'll just take 180, right? Well, first of all, we'll go 90. I can just go clear. I go 90. Minus my 25, and this angle is 65 degrees in here. And this angle is 50, right, from 90. And it's 90 because we're going east-south, right, northeast, southeast, so I got 90 degrees. And then if I add the 2 angles, I got 135 degrees, okay? Okay, now, what I have, if we step back from last week, is I really have my side, angle, side. I know side, angle, side, so I can find the opposite by the law of cosines. Okay, we're going to check out the law of cosines. So we're going to use the law of cosines. Okay, to find the law of cosines, here's my opposite. So I don't know if you guys remember, but I'll say it. Opposite squared, which is c squared, is equal to adjacent squared plus adjacent squared minus 2 times my adjacent times my other adjacent times the cosine of my angle. Okay, so it's been a 3-day weekend, and for Jason and I it's been even longer, but there it is, right? So it is opposite squared equals adjacent squared plus adjacent squared minus 2 times adjacent times the cosine of the angle. Okay, you guys remember doing that at all? Any fond memories? Got anything? Okay, so let's just do this in my calculator, find out what it is. So I'm just going to go, okay, what's 36 squared? I'm going to do the whole thing, right? Plus 24 squared minus 2 times.
Mr. Davies,
Yeah.
I think that your increment angle is wrong.
Isn't it 115?
Yeah.
Oh my goodness, thank you, 115. Thanks, I would totally get the wrong answer. Yes, it is 115. Good thing, yeah. Thanks, guys. Thanks, Caleb. 24 times, just in time too, cosine 115, and so I get an answer. But now there's no way that is 2,602.28 because that's c squared equals that, right? Right, that's c squared equals that, so we'll take the square root of that. So square root of that answer, and I get an answer about 51. And that's in terms of knots. Knots is just a term that boats use for distances. That makes sense? Boats don't do miles, they do nautical miles, which has to do with the degrees. Okay, so real quick lesson. So knots come from the fact that, our Earth is longitude and latitude. You with me? So a little bit of a history lesson, right? So then you go 1 degree is so many miles, right? And they take miles, they take a degree and divide that into minutes, and that's so many miles. And they divide that into seconds, and that's not. So it's 1/360th of a nautical of a degree. Okay. Anyway, so how far apart of the ship? There it is, 51.1 knots. Thumbs up. Not too bad. Can you do that on Friday?
No, probably not.
We'll practice it. Okay, let's turn the page, okay? Okay, now, example 2. We got this big old shape, and we want to find the area of it. What I can do is find the area of a triangle. So I do know the area of a triangle. Area of a triangle we learned was going to be 1/2 adjacent times adjacent times the sine of an angle. Okay, that's our formula for finding the area of a triangle, okay? But I don't see any triangles. Oh, that's easy. Let's make some triangles, right? Well, the first triangle I would probably try and make, let's see, probably right here. Let me see if I can make a triangle right here. I could go this way. It doesn't really matter, but I think I'll go here, okay? So I'm making 2 different triangles. I've got triangle 1. That's easy. And I've got triangle 2. A little bit more work. Triangle 1's not bad. So triangle 1, let's see. Triangle 1. So the area of triangle 1 is equal to 1/2 28 times 25 times the sine of 110 degrees. Okay? So I'm just going to use my calculator and get that. Am I going too fast? Okay. So I needed a triangle to use triangle form, so I just drew a diagonal through the quadrilateral to give me 2 triangles, triangle 1, triangle 2, okay? Triangle 1 is going to be 1/2 adjacent times sine of the angle, okay? So I'm just going to use my calculator, 0.5 times 28 times 25 times the sine of 110. I get an answer of about 328.9. 328.9 centimeters squared, okay? I'm going to circle that because I want to come back to that, okay? That's triangle 1, okay? Now, triangle 2, we got some problems, okay? Because triangle 2, what we need really is its side angle side. We need an adjacent. So what I'm going to do is this. I want to find this angle. Let's just call this angle here theta. I want to find that angle. Because if I find that angle, then I can find this angle here. Let's call that alpha. Does that bother you? That's alpha. You guys, you mind that symbol? That's my other angle, alpha. So I need that angle. It does look like a fish, doesn't it? Weird. And I also need this side here. Let's call this C. So that when I get down to it, I'll have my side here. I'm going to find this side, and I'll find this angle, okay? How am I going to do that? Well, let's go for the easy stuff first. For side C, we're going to find using the law of cosines. Okay, so I'm going to go C squared, opposite squared equals adjacent squared, plus adjacent squared, minus 2 times my adjacent times the cosine of my angle, right, which is 110 degrees. Okay, and that'll give me C. Well, C squared. But that'll take, so what I'm trying to do is get this side right here. I'm trying to get the length of the red line using the law of cosines. So all right, I'm going to put that in my calculator. I'm going to go 28 squared plus 25 squared minus 2 times 28 times 25 times the cosine of 110. Okay, and I get an answer, but I'm going to take the square root. So I get this big old decimal answer. But I'm going to take the square root of that. Okay, so there it is. Square root of that answer because it's C squared. So I took the square root of all that. C squared equaled 1,887 point blah, blah, blah. But I took the square root of that square root, right? So C turns out to be about 43.45. 43.45. Okay, I'm going to put that in my figure because I'm going to need that information, okay? So I found this side, okay? 43.45. Okay, now look, this is what we need, okay? This is what we need. I'll let you write that down. I'm going to go back to it. Tell you what we need, okay? So you know where I'm going, because at this point you're just drawing things down, going, whatever, Mr. Hughes, we have no clue what you're doing, right? But let me give you an idea of what we're doing, okay? So, ready? We need this formula, okay? So for triangle 2, we need adjacent. I have the 20, and I need adjacent. I now have adjacent, right? I've got that side and that side. Now I need this angle, because it's 1/2 adjacent sine of theta, but really it's theta, you can call it that, right? So I can switch these around. Does that help you if I switch these? Okay. Doesn't really matter. So let's find this angle, okay?
Can you do law of sine?
Yes, smart guy. So we can find theta by the law of sines. And once we get that angle by the law of sines, Jeremy, we can subtract from 180, right? And then we got our side, angle, side, right? So let's do that. Let's find this angle, theta. Smart guy. So Jeremy said, okay, let's find theta by the law of sines because I've got my opposites, right? I got my opposites, so we'll go, okay, I'm going to do that over here. I'm going to go and do my sine theta over 25 equals sine of 110 over 43.45, right? Got you guys that I'll multiply that up. Okay, so I'll go, okay, 25 sine of 110 divided by 43.45. And of course, I get a decimal because I'm looking for the sine inverse of that, right? Got a sine inverse of that. So I'm going to sine inverse that. Answer 32.65, right? So or 32.7 degrees. Okay, so that's 32.7 degrees. And now, to get alpha, this angle here, right? To get that angle here, to get alpha, we'll just take 130 degrees because the whole angle is 130, right? So if I go 100, so alpha is 130. If I subtract out my 32.7 degrees, I'll get that angle, okay? 130 minus 32.7. Again, about 97.3. Okay, that's 97.3. Okay, now finally I can find triangle 2. So to find triangle 2, I can go, okay, I go triangle 2, the area of triangle 2 is equal to 1/2. It's adjacent, which is 20. Okay, I gotta scoot this up. There you go. So area triangle 2 is 1/2, 20 times 43.45 times the sine of 97.3, and I'll get the area of triangle 2. Okay, so I'm almost done. I really am. So I go 0.5 times 20 times 43.45 times the sine of 97.3, and I get an answer of about 431. Okay, that's triangle 2. Now it gets easy. Now it's just simple math. So, centimeters squared. So, let's check it out. I've got triangle 1. I've got triangle 2. Let's add them together. So I'm just going to take triangle 1 plus triangle 2 equals total area. Triangle 1 is 328.9 plus triangle 2, 431. Okay, so let's add them together, and I finally got it. People do this. They don't do it like this anymore, but you know, if you're a surveyor for land, this is what they do. Okay, so about 759.9 centimeters squared, okay? Wow. How do you like that, huh? All right. So